Alright, problem number 3, first calculator problem. This is the hanging hippo problem, except this time it's a flamingo piñata. So, a 25-pound flamingo piñata is suspended from the ceiling by two cables. Cable 1 creates an angle of 73 degrees with the ceiling, and cable 2 creates an angle of 74 degrees with the ceiling. So, if you can picture this situation, there's our ceiling. We've got two cables coming down. First one, 33 degrees, and then the second one is 74 degrees, so much steeper like that. And then we have this flamingo bird thingy, pinata. I think that's what they look like. I didn't really know. But it is coming down right there like that, hanging, and we know that that thing weighs 25 pounds. So this is the situation, and based off this we want to do a couple things. First thing we want to do is draw a free body diagram that represents the situation. So what I'm going to do is I am going to put my dot right here, representing my center of everything, where all the forces are balanced. Going, let's say, side to side, I know the horizontal components of my two vectors need to be balanced. Need that since the flamingo is not going to be swinging side to side. It's stationary, so the horizontal component of the first vector needs to balance with the horizontal component of the second vector. So I'm going to draw those coming out, and I'm going to make them the same distance because the distance of the vector is representing the magnitude, and I know they have to be balanced because they are being represented by those forces. So those are balanced. I know the left one is going to shoot up at an angle of 33 degrees, so it's going to look something like that. And then I will have my vertical component going up there. And then on the right hand side, I have my angle going up much steeper at 74 degrees. So something more like that right there. And then I have that vertical component again going up. And then the last piece that I have is the force pulling down, coming from gravity acting on that flamingo. And I know that since my flamingo is neither moving up nor down, that the line that I draw down needs to be balanced with the two purple vertical components of those other vectors, which means it needs to be the same length as the two of them combined. So maybe something right around like that. And then a couple other pieces I know. I know that the force pulling down is 25 pounds of force. And I know a couple angles. I know this angle is 74 degrees. And I know this angle is 33 degrees. So not totally to scale, but pretty close. Let's label the cables. T1 as that first tension and T2 as that second tension. And now that we have that labeled, we can label each of the components. The vertical components are just going to be the vectors times the sine of the angle. So here I'm going to get T2 times the sine of 74 for that vertical component. Here I'm going to get T1 times the sine of 33 for that vertical component. And then same idea here for the horizontal components, except cosine instead of sine. So I'm going to get T1 cosine of 33 and T2 cosine of 74. So now we have the free body diagram labeled as completely as we can. So now part B says to write a system of equations that can be used to find the tension in each cable, T1 and T2. So we have two unknown values, T1 and T2, and so we need to write two equations. One equation we can write comes from balancing the vertical components. We know that T1 times the sine of 33 plus T2 times the sine of 74 has to equal 25 pounds. The downward force has to perfectly match the upward force. And then we can do the similar thing with my horizontal components. I know I get the equation T1 cosine of 33 equals T2 cosine of 74 because my horizontal components need to be balanced as well. So they have to be equal. So I'm going to rewrite that last one as T1 cosine of 33 minus T2 cosine of 74 equals 0. And you hopefully know why I did that. But now let's go ahead and write this as a matrix to enter into our calculator. When we do that, we're going to get a T1 column, we're going to get a T2 column, and then we're going to get a column for what these values are equal to. So, first equation, purple one, I'm going to get the sine of 33 in my T1 column, the sine of 74 in my T2 column, and 25 in my equals column. Pink equation, look at the bottom one. T1, I have the cosine of 33. T2, I have the negative cosine of 74, and that is equal to 0. So that is my matrix, my system of equations, my free body diagram, and now we just need to plug this into our calculator and find our answers. So hit the second button, hit the matrix button right there. It will pop up listing A, B, C, D, all the different matrices. Go over twice to hit the edit button right up there, and then hit enter to edit matrix A. Once you're into matrix A, make sure you enter this as a 2 by 3 matrix, and then go ahead and enter each of those values in. Hit enter and it will skip to the next one. Make sure you're in degree mode, otherwise your answers will be bonkers. And then once you've filled out the last one, hit second, quit to go back to the home screen, then hit second matrix again. Scroll all the way down or up until you see option B, which says RREF. Once you've done that, it'll print it to the home screen once you've selected RREF, and then you can hit second and matrix one more time, and then hit enter to select the matrix you just chose, which was matrix A. Hit enter, and it will tell you your answer in the form of a matrix. You should see a matrix that looks like that once you've hit enter, which is telling us that the tension in T1 is 7.206 pounds, and the tension in T2 is 21.925